basically will inform every single kind of dimension that we're looking at. It's about clienteling or supply chain, it's about data, isn't it?
Yeah.
Data. So I think if because we don't, I'm not like from that, do you know what I mean? And I think you know, from an industry perspective, you know, you do it, data is your business, isn't it?
Yeah, and if you ever did anything, I'm trying to think what my strengths would be. If you anything app related, obviously, I'm happy to help with anything like that. Also, how the digitalisation of retail, because we did with the app, it would basically gamify retail. So the other avenues than just having a website, what are companies doing? You've got their NFTs, you've got apps now. People are going to get much harder themselves, doing gaming, trial experiments to that, and how is those avenues converted into revenue? Because there's a lot of especially luxury brands that are playing with that space, but more for less. But it's not converting to money. So it's how is it becoming beneficial to the bottom line, not just like something that is getting the Instagram a bit.
So it could be a case of, because we've got a master's course as well, we do omnichannel retail.
Yes, that's amazing.
So that could be a great guest section as well. So maybe somebody can go try and find a day where you do the underwrites for the consultancy project, and then go into post-grad afternoons and things like that.
Amazing. I'd love to do anything like that.
No, well, she's just texting.
Oh, does she?
She's just left.
Right. So
she said, tell her we must arrange. She's like, what a shame. Tell her we must arrange a meeting and have you to give them my phone number.
Oh, okay. Cool.
Yeah,
because she's my next target to speak to, you see. Because now I know me and you are on the same page, I just need to tackle Rachel. Oh, amazing. Well, it's been amazing to meet you. Lovely to see you. Thanks for my coffee. I've really enjoyed chatting, and it's nice to know that kind of your perspective. I think we're on the same page in terms of perspective and outlook. So that's really exciting.
Well, definitely, I'll send you Siobhan's details as well, because you could probably tap into about what she does outside of my notes. The fashion, new fashion talent and stuff. She's based in the south anyway.
Oh, is she?
Yeah, she's based in London. Even though her background, she's from Wakefield.
Okay.
She's from the north. She's from Leeds.
She's a good Northern.
Yeah, that's why she's really passionate about retaining talent here.
That's not yours, is it?
Okay, good afternoon, class. So let's start the our session today. Now, as before, I would like to, before we work on the worksheet, I would like to give you an overview of some formula that we can widely use for doing hypothesis test when we obtain data from one sample. And next week, we will deal with the two sample problems. Now, actually, you will find a lot of similarity with the construction of confidence interval because we need to calculate similar things. But the idea of hypothesis testing is quite different from estimation or constructing confidence interval. Now, the purpose of doing hypothesis test is to test the truthfulness of a statement. We are interested in a statement about the population, but we don't know whether it is true or not, so we would like to have some data, since whether the data provides some evidence for us to accept it or reject it. Now, there are some formula under different scenarios, just like confidence interval. If you are doing the test on the population mean, so mu represents the population mean, which is unknown. But you want to test whether it is equal to a hypothetical value, not like whether the mean is equal to 1,000, whether the mean is equal to 10, whether the mean is equal to 5. So this number is a hypothetical value, in general represented by mu naught in the formula. And if you know that your sample was drawn from the normal distribution, so in the question, it is stated already that the sample was drawn from the normal distribution. And if the population variance is low, then the test statistic, the statistic that we will compute and make use of this to do the test, we call this the test statistic, will be given by this formula. Now, this formula is actually corresponding to this general form. An estimate, a point estimate of the unknown population mean, we compare with the hypothetical value stated in the null hypothesis, divided by the standard error of the estimate of the population mean. So actually this statistic takes this form: a point estimate minus a hypothetical value stated in the null hypothesis. We usually call this the null value. And then divide standardizing using the standard error of the point estimate. And since we are estimating the population mean, so the point estimate is the sample mean, we compare it with the hypothetical value. And standardizing using the standard error. Now, depending on whether you know the value of sigma or not. If sigma is low, then the standard error will be sigma over square root n. So we divide by sigma square over square root n, we obtain this expression. And we use this quantity as a test statistic, because it is a comparison between the sample mean and the null value. So it depends on the alternate hypothesis. Then we can consider how to obtain the critical region. Now, there are three kinds of alternate hypothesis that we can consider. One alternate hypothesis is that mu not equal to mu naught. We call this a two-sided test, testing on the both sides of the hypothetical value. If you have this alternate hypothesis, then looking at this, considering this form of the test statistic, whenever there is a large deviation, no matter whether it is positive or negative, as long as the sample mean and the null value are deviating a lot, that will be an evidence for us to reject the null hypothesis and accept the alternate hypothesis. So that we will reject the null hypothesis whenever this number is too large or too small. Or in other words, when the absolute value, when the magnitude, this is the magnitude of this, removing the sign. When the magnitude of this is too large. How large is large? We compare with the quantum from the normal distribution. So this quantum is the quantum corresponding to this region. Okay? So that these two regions combined together will reveal the power. Alpha is our so-called significance level. So this is how we do the test for this alternative. If, on the other hand, you are only interested in testing on one direction to see whether mu is substantially greater than the null value. So we may test on the right-hand side of the null value, towards the right-hand side of the null value. So it is a one-sided test. And we will reject the null hypothesis whenever the sample mean is much greater than the null value, because the sample mean is an estimate of the population mean. So when this is greater than this a lot, then there will be evidence for us to accept this one and reject this one. So that we will reject the null hypothesis. If you have this alternate hypothesis, we will reject the null hypothesis whenever the value of z is too large. This time larger than this number. Because we are doing one-sided test, so we don't need to divide the area by 2. So we'll consider this area only. And similarly, for this alternate hypothesis, we reject the null hypothesis if z is too small. When sample mean is too small compared to the null value. So we will test towards this direction. Okay? So this is how we do the test under this scenario. Okay? And actually, if the distribution, you are not told that the distribution is normal. But as long as you have a large sample, you can also do the same thing. Just like in constructing confidence interval. Now there is another scenario that you have a sample from the normal distribution, but you are not given the population variance. So when population variance is unknown, of course we need to replace it by the sample standard deviation. Just like in constructing confidence interval. And the quantile will be also replaced by the corresponding t quantile, also similar to constructing confidence interval. Of course, if sample size is large, then we will compute this test statistic. But for the critical region here, the rejection region here, these quantiles will be replaced by using the normal quantile, if sample size is large. Because if this n is large, all this will be very close to the normal quantile. Now there is also a problem. Sometimes you encounter the problem testing the hypothesis in terms of the population standard deviation. So this will be the test statistic using the sample standard deviation. And sigma naught is the null value for the population standard deviation. And this will be the critical value that can be obtained from the chi-square distribution value. Finally, we have the one sample test for proportion. If the hypothesis is stated in terms of the proportion, we may want to test whether the population proportion is equal to a null value. Then this will be the test statistic stated in the written note of the lecture. Okay? You see this one. This also tests the form of the point estimate minus the null value divided by the standard error of the point estimate. So the reciprocal of this is the standard error of the sample proportion. This bar is the sample proportion. But actually, in some textbook or some other literature, and even in the solution of this worksheet, you will see another formula for this test statistic. Instead of using the sample proportion in the denominator here, some may use the hypothetical value P naught, the null value in the denominator. Now both can be used actually. They are not different, but as long as sample size is large, both will be more or less the same. So sometimes you see people would like to use this one, but sometimes you see people use this one, even in this course. In the solution of the worksheet, you will see this was used. And this will be the corresponding rejection regions. And this rejection region actually are quite similar to the rejection region for the normal, for the mean problem, for the normal sample. Is there any question? Now these are the formula that you may use for doing one sample test. Okay? For the two sample tests, I will we'll see, I'll explain in details next week. So now we can try to work on the worksheet. Maybe you can spend a little time, if you didn't do so yet, try to work on question number 4 to see whether you can find out the correct way to solve this problem. Okay, I can see most of you can get the answer of the first part of this question right, but the second part may be a little bit difficult to some of you, so maybe I will explain in details. So in part one, first of all, we need to identify what formula we can use. In the question, we are told that it follows the normal distribution, and we are also given the standard deviation 8.7. So we can use this test statistic when the population standard deviation is low. And we reject the null hypothesis according to the alternative. We are testing a one-sided hypothesis to the right-hand side of the hypothetical value 250. So we reject the null hypothesis if the test statistic is greater than this normal quantity. And since alpha is equal to 0.05, so the normal quantity is obtained as 1.645. So this will give you a procedure to do the test. So next, we just substitute all the information we have into the formula to compute the test statistic, compare with this critical value, and then draw the conclusion. So we do the calculation. The sample size is 20. The sample mean is equal to 252.96, and the hypothetical value, the null value in the null hypothesis, is 250. And the standard deviation is given as 8.7. So we do the calculation. It is equal to 1.521. So it is not greater than the normal quantity. It is not greater than the critical value. So that means we do not reject the null hypothesis according to the test procedure. So H0 is not rejected at 5% significance level. Okay. So the meaning of this is that the data didn't provide enough evidence for us to reject the null hypothesis. The data didn't show strong evidence to claim that it is false. That's the conclusion that we can draw. After we draw them, we obtain this test result. So this is easy. Now part 2 is a little bit more difficult because we are asked to compute a probability. Calculate the probability that your test will correctly reject the null hypothesis when the true value is not equal to 250, for example 255. So we need to compute how likely that if the mean is equal to this, how likely that we will reject the null hypothesis. So first we need to find out under what scenario we will reject the null hypothesis. That is when this is greater than this. So whenever we observe a sample with the mean computed after computed value greater than 1.645, we will reject the null hypothesis. We need to calculate how likely this will happen when mu is actually equal to 255. So we want to compute the probability of reject H0 for a particular value of mu. So it is equal to probability, that's this number, when the population mean is equal to mu. Now note that this is not following standard normal because it here says that the mu is actually equal to 250. In fact, we want to compute how likely this will happen when mu is equal to 255. And therefore, we need to change it into mu. So that this will follow the standard normal. So that we need to adjust the right number on the right hand side to make this inequality to be equivalent. Okay. So on both sides, we just move some quantity here and then minus mu over multiplied to square root 20 and over 8.7. So that the left-hand side, this quantity, for a particular population mean, for any population mean, this number will follow the standard law. So we need to compute the normal quantum. So it will be equal to 1 minus the normal probability, 1.645, minus this number. And therefore, we can put mu equal to 255. So we substitute mu equal to 255 into this expression to compute the probability. So I'm not going to go through the detail. This is a standard step to find the normal probability. So usually you will find this probability. It is equal to 0.8 something. So in other words, if you do this test, following the test procedure, if the true population mean is actually not equal to 250, so that is not is false. If it is actually equal to 255, then you will have this chance, at least 80% chance to correctly reject the null hypothesis. And we can also do this calculation. For the other value of the mu. For example, in the question it says that we are also asked to compute this probability. If the population mean is actually equal to 257, what is the chance that we can correctly reject the null hypothesis? So we do the calculation again, but this time we use mu equal to 257. And you will see the probability will gradually increase. So that means if the actual population mean is really deviate more from the null value, then you will have a larger chance to reject it correctly. So that is actually the idea of doing this calculation, comparing these two probabilities. Both probabilities correspond to the probability that when the H0 is not true, the chance of correctly rejecting it. But when the null hypothesis is not true, there can be a lot of different scenarios. Whether it is very, very not true or less not true. Is there any question? Now, maybe you can work on question number 5. Actually, this will be similar to the previous one. size of the other which is a large sample. A large sample for T will be done. So we are approximately using Z in the examination because we can access the output. We can only give the table will be answer. Table is not large enough. That's a T. But actually you find it. But if you cannot find the exact value, probably you can possibly find it. Okay, for this question, it is similar to the previous one. But this time, you are also told that the distribution is normal, but the standard deviation this time is unknown. So that we may need to use the t-test. So the test statistic would be the same as the previous one, similar to the previous one. However, the denominator here is not sigma because it is not known. So we replace it by the sample standard deviation. And we reject the null hypothesis. According to the alternate hypothesis, it is a two-sided test. It is on the two sides of the null value. So we need to take the absolute value. We take the magnitude of t. When the magnitude of t is too large, larger than the critical value, and for the two-sided test, we need to divide alpha by half to allocate to the two ends of the distribution. Now notice that here, n is equal to 54. So the degree of freedom is equal to 53. Actually, it's quite large. So we need to determine this quantity. Now, of course, if you can access R, you can easily find this using R function. And it is equal to 2.006. If you can access the R function, use R program, then you can use the function to find this. But in the examination, probably in the written examination, you cannot access the computer. You can only access the given table. In the table, you will find that there is no such default freedom in the table. The table is not fine enough. Okay? You can find the default freedom 40, and then you jump to 60. There's no 53. So somehow you may need to make use the numbers obtained from 40 and 60. Then you will find that this number. You will know that this number is something in between. Or you can approximate by using normal. The reason is that for large n, the t will actually converge to the standard normal when the sample size, when the degree of freedom tends to infinity. So that means if this degree of freedom is large, in other words, when the sample size is large, the t critical value can be approximated by using the normal critical value. Okay. So this will be a appropriate approximation. Not exact value, but it will be a reasonable approximate. So now in this question, we can compare the test statistic using the sample data we are given. The sample size is 54. Sample mean 66.3. And the hypothetical value, the null value is 64 in the null hypothesis. divided by the sample standard deviation, which is given as 9.2. So this is our test statistic. So no matter whether you use this one or use this one, the exact value or the approximate, you'll get the same conclusion. The magnitude, don't forget we need to take the magnitude. So that means if you compute this quantity, you find that it is negative, you still need to take away the negative sign because we are doing the two-sided test. So the actual value, the magnitude of this is 1.837, not greater than the critical value. So again, H0 is not rejected at 5% significance level. So we also don't have enough evidence to reject the null hypothesis that the mean is equal to 64. Okay. Is there any question? Now, because I don't have enough time, so maybe I will just explain how we can tackle this problem, which is a problem in terms of the population proportion. We have seen how we can do the one-sided test for the population mean in case when the population variance is known and unknown. Now here is another possible question that you encountered, that is a problem involving population proportion. So P is an unknown proportion of the population who concerned with the lack of educational program in theory. So we are asked to propose a suitable test statistic for testing hypothesis. Now this is a one-sided test. See? We test the P equal to half against the alternative P greater than half. So it is a one-sided test towards the right side of the null value. And among those formula that you've only learned one formula for the test for the proportion. So the test statistic is this one. Now as I mentioned before, there are two formulas. You may use the sample proportion here, or you use the null value here. I just follow the solution, because in the solution you find that this is used. Okay? And we will need to find the critical value for doing the test. How we can compare this with the critical value to draw the conclusion of the test. Because we are doing a one-sided test towards the right-hand side of the null value, so we reject the null hypothesis if this test statistic is greater than this content. And we don't need to divide alpha by half because we are doing a one-sided test. We don't need to allocate to both sides. So now we can carry out the test. We just follow this to compute the test statistic and draw the conclusion according to this comparison. So in order to compute this test statistic, we need the sample proportion. According to the question, it says that the sample size is 920. Out of this surveyed individuals, 848 of them concerned about the lack of educational program. So the sample proportion is equal to 478 divided by the sample size to 920. So this is the sample proportion up to 4 decimal places. So we substitute into the test statistic. Now the null value here is 0.5. And it will be given as 1.1869. Okay. You may try, instead of using this formula, you may try to use the sample proportion in the denominator. Put in 0.1596 here and 1 minus 0.1596 here, and you'll find that the number actually are quite close to each other. So we compare this one. We find that it is less than the critical value, not falling into the rejection region. So we also draw this conclusion. Okay, this is how we draw the conclusion. The data didn't provide enough evidence for us to reject the hypothesis that P is equal to 1. Any question? Now, part 4 is actually quite similar to question number 4. We are also asked to compute the probability of correctly rejected hypothesis for any particular value of P value equal to 0.55. Actually, we are doing the same calculation. We reject the null hypothesis if this test statistic is greater than 1.645. So we reject the null hypothesis whenever this happens. And we can write this as equivalently as x bar greater than 0.5271. We just do the solve this inequality. We move this part, divide both sides of this part of this inequality by this quantity. So we divide this number by this number and then add 2.5, we can get this number. So this is the scenario. Under what scenario we reject the null hypothesis, whereas sample proportion observed is greater than this. So we need to compute the chance. The sample proportion greater than we want to find the probability reject the null hypothesis when P is equal to 0.55. So we want to find the probability this happen when P is actually equal to 0.55. So we standardize both sides by using the normal the normal standardization. So I don't have much space here. So we just need to compute this probability when P is equal to 0.55. So we need to use the normal approximation to standardize the left-hand side into a standard normal. So this will become standard normal when P is equal to 0.55. So when we do this standardization, we also need to standardize similarly, accordingly, on the right side. So this will become a normal probability calculation. And you'll find that the chance is quite high. So if the actual probability is equal to 0.55, we have 92% chance to reject the null hypothesis. So I just hope that you can try, maybe at this moment you cannot digest everything, but try to see whether you can follow. Because it is a standard step. It is a standard step to compute this probability. And you will encounter it quite often, probably in the assessment, in final assessment, or in the coursework. How you can compute the probability of correctly rejecting a null hypothesis for different value of the parameter. We call this the power. Okay? The power of the test. The power of test to correctly reject the null hypothesis. Okay? So it is also another quantity telling us whether the test is reliable. If it is not true, if the null hypothesis is not true, how likely that we can correctly reject it? It's very difficult. And this is a typical step how we can compute this problem. Okay? So is there any question? So if there's no question, we can end this session and see you next week.